In the previous videos, we talked about the definition and representation of set, and we learned how to describe a set and what are the relationships between sets and how to prove those relationships. In this video, we will learn what kind of operations we can perform on a set and on multiple sets. Before we talk about the set operations, I will first introduce three concepts that are related to the set operations. The first one is the size of a set. Here is the definition. The size, or sometimes called cardinality, of set S is defined as the number of elements in set S. And here is its notation. It's like the absolute value operation in algebra. Let's see some examples. If set A is the set of odd positive integers that are less than 10, then we know that A consists of 1, 3, 5, 7, 9. Therefore, the size of A is 5. If S is the set of letters in the English alphabet, then we know that the size of S is 26. And remember this special set, the empty set? Since the empty set contains no elements, therefore the size of the empty set is just 0. And this set, still remember what it is? This is a set of non-negative integers. Therefore, the size of it is infinity. The second concept I want to introduce is power set. For a given set S, the set consisting of all the subsets of S is called the power set of S. And here is its notation. Again, to use an analogy from algebra, this is just like the exponent. However, here 2s is not 2 to the power of s. This is a set. Therefore, we can use this to describe the elements in the power set of S, where each element x is a subset of S. Let's see one example. If S is this set consisting of 3 elements, A, B, C, and what is the power set of S? You can pause the video and try to write down the power set of S. In order to write down the power set of S, we need to know what are all the possible subsets of S. And since there are quite a few of them, if we do not want to miss any of them, we'd better write down the subsets in a certain order. What order can we use? We use the size of the subsets. Now let me ask you a question. What is the smallest subset of S? Some of you may say it's 1 because you have 1 element in the subset. That is not exactly correct, because when we learn the relationship for sets, we said the empty set is a subset of any set. Therefore, the smallest subset of S is the empty set. So this is the only set of size 0. Now we can move on to all the subsets of set 1, and we know that there are 3 of them. And similarly, there are 3 subsets of S that consist of 2 elements. And here they are. Do not just stop there, because there's one more subset of S, which is the set S itself. Now we completed all the subsets of S. and you put them all in one set, in other words, in a pair of brackets, now you have your power set of S. If you count it, there are 1, 2, 3, 4, 5, 6, 7, 8 of them. Okay? What if S consists of 4 elements? Let's say there's another element D in it. How many subsets of S can you find? Or in other words, what is the size of the power set of S? Here's the equation you can use. In general, for any given set S, the size of the power set of S is 2 to the power of the size of S. For example, in the previous example, the size of S is 3. Therefore, the size of the power side of S is 2 to the third power, which is 8. Now you can answer my previous question. If S has 4 elements, then the size of the power set of S is 2 to the 4th power, which is 16. Now let me ask you the question. What is the power set of the empty set? Some of you may say it's just empty set because there's no element in the empty set. Therefore, the power set of the empty set is also empty set. That's not true, because according to the definition, the power set of the empty set should include all the subsets of the empty set. And we know that there is one subset of the empty set, which is the empty set. Therefore, the power set of the empty set is not empty. It has one element, the empty set. And therefore, the size of the power set of the empty set is 2 to the 0th power, which is equal to 1. Next concept I want to talk about is called Cartesian product. Here is the definition. The Cartesian product of A and B, which are 2 sets, is denoted by A cross B. And it's defined as this set. Here you can see the element in this set is not an element in the original set anymore. Instead, each element in this set is the ordered pair, where X is from A and Y is from B. More importantly, since it's an ordered pair, we call X the first value, Y is the second value. Let's see one example. A is this set, B is this set. So what is A cross B? By definition, it should consist of all the pairs where the first value is from A and the second value is from B. The first value could be 1, and second value could be 2, and the second value could be 4 as well. And for the first value of the pair, it can also be 2. And A cross B is this set. What about B cross A? You can pause the video and write down this set. B cross A is 2, 1, 2, 2, 4, 1, and 4, 2. Did you get this right? Next, let's see some fun facts for Cartesian product. A cross the empty set is still empty set. Why? Because you will not be able to create any ordered pair since there's no element in the empty set. Similarly, the empty set cross A is also the empty set. And A cross B is equal to B cross A if any of the following two conditions is true. First, if A and B are the same set, then of course the order does not matter. Or you can see from the first fun fact that as long as one of them is empty set, either A cross B or B cross A is the empty set. Therefore, they are the same set. Next, the size of A cross B is equal to the size of A times the size of B. Why? To put simply, basically, for the first value of the pair, there are the size of A possibilities. And for the second value of the pair, there are the size of B possibilities. Therefore, the total number of pairs you can create is equal to the product of the size of A and the size of B. We'll talk about this in detail when we talk about counting. Next, what if we extend the equation to 3 sets? Usually, in general, A cross B, then cross A is now equal to A cross the Cartesian product of B and C. Why is that? This is because for A cross B, each element is in the form of ordered pair. And then when you cross C, each element will be something like this. This is from A cross B, and this is from C. But for this one, B cross C will be in the form of an ordered pair. But then, when you use A cross this Cartesian product, each element will be something like this. This element will be from A, and this pair will be from B cross C. As you can see, the format of the element in each of these two sets are completely different. Therefore, in general, they are different. But now, my question for you is, when are they going to be equal? Here, you can see, even when A, B, C are all the same, these two are not the same, are not equal. So this is different from Cartesian product of two sets. So when can they be equal? The answer is, as long as one of A, B, and C is empty, these two will be equal. Why? Because as long as one of them is the empty set, this will be the empty set, and this will be the empty set as well. Note that A cross B inside of parentheses cross C is not the same as A cross B cross C. Here, A cross B cross C is a set of 3 tuples, where the first element is from A, the second element is from B, and the third element is from C. You can see the format of each element in these two sets are different. Now, since A and B can be any set, when A and B are the same set, A cross A is denoted by A2. Here we read this as the Cartesian square of set A. And this can be generalized to An, and we read this as the n-ray Cartesian power of set A. And here you can see there are no parentheses around the sets. Therefore, each element of this set is a pair. Each element of this set is a 3-tuple, and each element in this set is an n-tuple. Next, let's see one example. If A is a set consisting of 1 and 2, then the Cartesian square of A is this set. Because the first value of the pair could be one of these two values. So we have 1 and 2. And similarly, the second value can be either 1 or 2. Therefore, you have 2 times 2, 4 elements. As a practice, you can try to write down A3. Remember, in A3, each element is a 3-tuple, where the first value could be any of the two values, the second value could be also any of the two values, and third value can also be any of the two values. And therefore, there are 8 elements or 8 3-tuples in this set. Here is A3.